Assalamu alaikum and welcome again to Idri with you Ali Idris, and today video is gonna be about allocation functions in C language. We're gonna discuss four type of functions: calloc and free and malloc and realloc, and all are related to the memory basically. So we're gonna explain each one how it works and the syntax and what it does. After that we're gonna jump to a program. We're going to see in a real how this function work. Okay, now as you see on the screen, there is allocations folder. Okay, I'm gonna create another folder inside of it. I'm gonna start with the malloc function. I'm gonna start malloc. Inside this malloc I'm gonna create another file. I call it malloc.c. okay, so what it is cmalloc? Cmalloc method or memory allocation method in C is used to dynamically allocate a single large block of memory with the specified size. It returns a pointer of type void, which can be cast into a pointer of any form. It doesn't initialize memory at execution time, so that it has initialized each block with the default garbage value initially. So the syntax is going to be like ptr like pointer, okay, and we're going to set it equal to the cast type. I'm gonna like add a dash type here, the cast type pointer. So this cast type, it can be float, integer, double, anything. Then we pass the function malloc. Okay, then here inside of the function malloc we're going to pass the byte size. So byte dash size like this. So for example here, let me say that this cast, it is, so let me remove this. So this cast type, it is for instance integer, so we're gonna pass it integer int, and the type byte size is gonna be for instance 100 multiply by the size of int, okay, like this. So here, since the size of int is 4 bytes, this statement will allocate 400 bytes of memory, and the pointer ptr, this pointer, holds the address of the first byte in the allocate memory. Okay, so now we're gonna jump and see this in real life. So we're gonna delete this and just type code to bring the syntax. Let me remove this sidebar. Okay, so inside of here we're gonna find like int pointer to an array, and we're gonna like create size and I for the looping. So we're gonna like print here something. If you don't know anything of this function, I'm gonna leave you a video in the description that I gather anything about C language. So enter size like this, and we're gonna scan function, pass the format specifier. For the integer it is d, and the address of size like this. After that we're gonna allocate the array using the malloc function by doing this the syntax int as soon as we're using integers, and here passing the function malloc, right? After that the size multiply by the size of int like this. Okay, now we're gonna check if the memory creator successful or not. Okay, we're gonna print, or if array it is equal exactly to null, that basically means that the array it's null, it has nothing. We're gonna print like the creation field. Okay, the creation like printf the creation field. Okay, I'm gonna pass like exclamation mark, do a new line, and print the memory not allocated. Print the memory not allocated. Okay, let me add like a new line and exit with the code 0, so exit 0 to get out of the program. Otherwise, if the memory created, what we're gonna do, we're gonna like print a message that says the memory created accessible with malloc. The memory created successful with malloc function, and add a new line, go at the end, add semicolon. Now like here we're gonna get some elements because we want like printing the element of the array. Okay, so get element, let me comment get element of the array, and here we're gonna run a for loop. It's gonna be size I, we're defined it at the top, and here the count is gonna be the size. Okay, because we took it at the beginning, here it is, and we entered the size. After that, here all what we have to do, it is just to say array at E. So array at E, it is equal to I plus 1, like adding 1, like this. Let me remove this. Now we're gonna display the element. Display element like this. Run a for loop, and it is I. The count is gonna be size, and say printf, and format specifier, add a space, and then pass the array at E. Okay, this is clear. Let me run the program by going to run code. Let me run the terminal on the right. So here the program, it is compiling. Like give it a second until the compilation complete. I think the code is good. So let me say for elements, so the memory created successful with malloc, then pass the elements. Okay, this we used like incrementing each time 1 up to the size, and by starting I with 0. Okay, we could just type it here if you want, but we use this statement here. We set I equal to 0, and just this. I think everything is cool, and you could play around with this if you want to get the element by your you want to get them. So let me comment this, or just let me cut it from here and say scanf function, and then pass the D, and here is gonna be array, the address array at E, like this. So it's better actually to give like a message here, enter element, print enter element, or numbers like this. So let me run it again. Give it a second. For elements, the memory created successful with malloc, enter elements. I'm gonna say 8 9 7 and 4 6. So 9 7 4 6. So this is how to use malloc function. After we've seen the malloc function, now we're gonna say the calloc function. So here again, we're gonna create another folder inside. So let me close this here and name it calloc. Create another file and call it calloc.c. Let me clear this on the right, clear. Okay, so the calloc method or contiguous allocation method in C is used to dynamically allocate the specified number of blocks of memory of the specified type. It is very much similar to malloc but has two different points, and these are: it initializes each block with a default value 0. It has two parameters or argument as compared to malloc. So the syntax is going to be like this. So the ptr, because pointers, is going to be cast type, okay, type, and the pointer, of course. And here we're going to pass the calloc function, and it's going to be the size, as I said, and the element size, element dash size. Okay, so here in is the number of elements, and element size is the size of each element. So for example, the ptr is going to be equal, if we using floats, so float, and then pointer calloc, then it's going to be here the size, for instance 25, and here the size of the float, like this. Okay, so this statement allocates contiguous space in memory for 25 elements, each with the size of the float. Okay, so we're gonna now see a real world example in C language. So we're gonna jump the code. This is just the syntax. Okay, here we're gonna initialize with defining int pointer array as we've done before in malloc. Okay, getting the size, printf size equals 2, then scanf the size using this format specifier address size. Okay, here dynamically allocate the function, dynamically allocate memory using calloc function. Let's do this, and here the array is going to be equal, as I said, the typecast here ends but the pointer calloc, then the size here is going to be size, and here size of the int. Okay, now it's clear. Now we're gonna check if the memory has been successfully allocated by calloc or not. So we're gonna do the same. If the array equal exactly null, this means that the allocation failed. Print allocation failed, allocation with calloc failed, like this, new line, and exit with 0, exit with 0, like this. Otherwise, if it's not, that means that the memory is successfully allocated. So else print if memory allocated, memory located, like this, or just point new line. And here now we're gonna get the elements. So get element for I, we define it up to the count, and it is size, the code here. We're gonna say, for instance, the multiplication of each element. So we're gonna say I multiply, for instance, by 10, and let's add 10 to it, for instance. This is just an example. You could play around, do whatever you want here. It doesn't matter. And now we're gonna display prints the element okay, new line, and here we're gonna create another for loop. It is the size here. I'm sorry, here's the size, and here printf format specifier, do a tab, and here pass the array at a I. So let me remove this. I hate a lot of lines in the code. So let me run it again, or run it at the first time and see what happened. So the size, let me say 4. So memory allocated well. The element, it is 10, 20, 30, and then 4. Okay, why? Because it is 0 the first time. It's gonna be 0 by 10, it is 0, plus 10, it is 10. Then secondary time is gonna be 2 multiplied by 10, it is 1. First, after 0 it is 1, so 1 by 10, 10 plus 10, it is 20. Then 2 to multiply by 10, it is 20, plus 10, it is 30, and finally it is 40. And you could play around with that if you want. Now we're gonna jump to the realloc function. After ending with the malloc and syloc, as I said, we're gonna say the realloc function. So we're gonna create another folder, realloc dot, or just folder, then pass the code and say realloc.c. Again, what it is, the realloc or reallocation method in C is used to dynamically change the memory allocation of a previously allocated memory. In other words, if the memory previously allocated with the help of malloc or calloc is insufficient, okay, realloc can be used to dynamically reallocate memory. A reallocation of memory maintains the already present value, and new blocks will be initialized with the default garbage value. So the syntax of realloc is going to be like this: ptr, because we use pointers of course, it's going to be a realloc like this, open parentheses, ptr again, the pointer here, and the new size that we need to realloc with it. Okay, so where the ptr or the pointer is reallocated with the new size, this new size here, if space is insufficient, allocation fails and returns a null pointer. Okay, so let us see a real world example. So let me type code and start here by defining int ptr, and of course the size and the I, like this. So let us just say the size equal, for instance, in this case 5, and here we're gonna dynamically allocate, okay, equal to realloc, where before we're gonna allocate we need to have like memory allocation or contiguous allocation, calloc or malloc function, malloc function. So we're gonna do now the int. I'm gonna use the calloc, and here pass the size and the size of int. So here basically what we've done, it is just dynamically allocate the function with calloc. So we could like add comments here. Dynamic locate memory using calloc function, like this. Okay, now we're gonna check if the memory has been successfully allocated by malloc or by calloc. I'm sorry. Let us see, check if the memory. So let me see something here. So this is the calloc. So the syntax of it is gonna be like this, and malloc is gonna be the syntax like this. Okay, just if you in case get wasted in here. So the size that we are here is in calloc, because if you used the malloc, it's not going to work. Check if the memory has been, if memory created, just like type created like this. Checking if ptr, if the pointer, it is exactly null. That means, or we need to print if memory does not created, okay, or allocated like this. As always, exit with the code 0. Exit with 0. We don't need to be here anymore. Otherwise, what we're gonna do, we're gonna print memory allocated, okay, no line, then get elements, get values or something, run a for loop up to the size, okay, size, and here we're gonna ptr as soon as we're using pointers, okay, and or the value equal to something, I don't know, let's do as the same as the previous example, multiply by 10. In this case we're gonna add instead of 10 add 100, for instance. Okay, it is the same example as before, it just here instead of 10 we used 100. Okay, now here we're gonna print element of the array, so like print the element. Now we're gonna pass or display the elements, print elements of the array are like this, new line, and here run a for loop, the size here, and print those by using printf function, format specifier, add a space, and we're gonna ptr at I. Okay, so now after getting this we need to update the size to something new. At the first case here we're putting the size to 5. Now we need to upgrade the size of the array to 10. Okay, so need in this case to use, so this is the case where we're going to use the realloc function. Okay, so here after that we're gonna just go get new size, and here let us set manually size to 10, and now we're gonna what to do, dynamically reallocate, okay, reallocate memory using what realloc function. So again ptr the same and realloc like this. Pass the argument, it's gonna be ptr, and then size multiply by the size of the int. And this, remember, this is the new size. If you used here new size, we're gonna pass here the new size. Okay, I should explain it first. Okay, so let me just delete it or comment it out like this. It doesn't matter now. Don't put your mind in it until we explain it. I think now everything is cool. Or I'm gonna do just run the program. Okay, give it a second to compile all the resources. And here we are. So the elements of the array are, so here is 5 elements, 1 2 3 4 5, the size is 5. And at the second place we reallocated the array with reallocates and passed 10 elements in different parts. You see here we add I plus 1, so 0 plus 9, 1 plus 9, and it is going for 10 elements. So this is how to use the realloc function. Now we're gonna jump to the last function we have, and it is free. The last function that we're going to say now, it is the free method. In C, used to dynamically deallocate the memory. The memory allocated using functions such as malloc and calloc is not deallocated on their own. Hence, the free method is used. Whenever the dynamic memory allocation takes place, it helps to reduce wastage of memory by freeing it. So the syntax is quite simple. Let me first create. Okay, let me go to here and say free. Add a file called free.c. So the syntax is quite simple. It is just passing the free function, then parentheses, and pass the ptr or the element that we want that you want to free. Okay, so right away we're gonna jump to example. So what I'm gonna do here, I'm gonna define int. I'm gonna define 2 pointers, pointer 1, or just leave it pointer, and second we're gonna say pointer 1 like this, and then define 2 size and I. Dynamically allocate the memory. So we're gonna say pointer equal to int. I'm gonna use now malloc function and pass here the size multiple by size of the int. I like this. And now we're gonna dynamically allocate the pointer 1 using the calloc function. So int pointer calloc, and here we're gonna pass the size and size of int. Quite simple, right? So the first for malloc and second for the calloc. After that we're gonna check if the memory has been created or not by doing if statement. If pointer 1 pointer is null, or pointer 1 is also null. like this. We're gonna print a message that says creation failed. Creation failed. Basically, here the allocation failed, but doesn't matter. It is just a message. Okay, now we are good. Now, otherwise, if it's created, what we're gonna do else, we're gonna print memory allocated using malloc. Print memory allocated using malloc, and pass parentheses, point new line. Okay, and then we're gonna free. What we're gonna free? We're gonna free the first pointer like this and go here. Secondary, gonna just copy this and do the same. And let me print something like malloc memory successful, or just freed. Well, for instance, new line. So let me copy this 3 messages or 3 steps and pass them again, and save memory allocated using calloc. Pointer, in this case it's gonna be pointer 1. So let me remove this pointer 1, and calloc here memory freed well. So now what we're gonna do, just run the programs. Let me get out of it and clear everything, then let me run it again. Give it a second until the compilation complete. So as you see here, memory allocated using malloc memory free well, memory allocated using calloc memory free well. So this is how to use this for functions in C language. I hope you get a lot of information, you get a benefit out of this video, and thank you for watching. See you for the next tutorials.